Okay, so for this two-dimension example, okay, we are going to be looking to find the force on the positive 0.8 microcoulomb charge. So that is this guy up here. I'm going to label this one A, because I like letters. How am I going to do this? I went A, B, C. Okay, so we're basically asked find the net force on A. Okay, so F net, and all of these forces are going to be electrostatic force. Okay, I just want to preface that here. I'm not going to put FE net into everything, although that would be proper. I'm just lazy. But I'm okay if you guys do this too. Okay, so F net of A is equal to what? What's acting on A? Perfect, perfect. So the force of B on A plus the force of C on A. I always laugh when I'm doing FB on A. I'm just like, huh, F bona. Not like that, but like bona. Like a bun. What? You sickos. Okay. Sorry, like bon A. Oh, really? Maybe I'm the sicko. There's actually a good market in Calgary. It's called Bonton Meat Market, and they sell really nice meat pies there. So, anyways. Okay, so let's do force of B on A first. It's going to be the easier one. Why?
Which one?
B. So I want to do FB. So force B on A first. I want to do this one first. Bona.
You have to do an X and a Y part.
Exactly. So when we do the force of Kana, F Kana, right? We're gonna have to break that into horizontal and vertical components. Okay, but for the force of B on A, this is just vertical, right? So I'm gonna start with that one. Again, Fe, the force of electrostatic, the magnitude of electrostatic force is equal to K Q1 Q2 over R squared. Okay, so I'm just gonna fix these right now. So negative 0.6 microcoulombs is negative 0.6 times 10 to the negative 6 coulombs.
Or negative 6 times 10 to the 7.
Yep, you sure could do that. Okay, here we have 1 times 10 to the negative 6.
We're smarter than you, basically.
Up here we have 0.8 times 10 to the negative 6 coulombs. And yeah, you could change that to 10 to the negative 7 for sure. Okay. And then 8 centimeters, this is 0.08 meters. 0.1 meter. And, we actually need to calculate this. I don't know what you want to call that one. BC? We need to also find the length of BC. I guess we may as well do that. Hey, so
100 minus 67.
46. No, 36, so it's 6. Yep.
I like that sound of that. So again, to find out, we do a squared plus b squared is equal to c squared. Maybe we should call that a different thing. Whatever. Minus b squared.
Yeah, C equals 6.
Yeah, exactly. I'm just gonna a is equal to that. C squared minus b squared. A is equal to the square root of 0.1 meter squared minus. Did I do that the right way?
Meters in it, so.
I gotta do the hypotenuse. Yeah, there we go. Times 0.08.
It ain't hard.
And then yeah, you guys you did it in centimeters. Yeah, but you still got
Sure. Well, it'd be 0.06.
Or 0.000 6 kilometers.
0.06.
Why are we in kilometers?
Makai's so smart.
Sean.
Or
Okay.
Wouldn't it be meters?
Yeah, that is meters, sorry.
Or be 600 millimeters.
Oh, you're so smart. You're so smart. Striker. Hero brownie.
Oh.
Okay, so now that we found that missing length for our triangle, we can go ahead and solve that.
Huh?
So force of B on A. Okay, you guys alright? Good.
I didn't even say anything. I'm not part of this conversation.
So force of B on A is equals to K
Go for it.
times Q1. So 0.8 times 10 negative 6 coulombs multiplied by B. So 0.6. And I am leaving the negatives out. Okay, because I'm going to analyze it after. Okay, remember this is an absolute value. Formula. 0.6 times 10 to the negative 6 coulombs divided by our separation distance, which is 0.08 meters. Don't forget to square that. I got 0.67425
Yeah.
newtons. And what do we have here? Attraction or repulsion?
That's attraction.
That's attraction. Very good.
Bonus.
Positive and negative. Good. Okay, so let's ask ourselves what does that mean? So we're looking for A. So what is that gonna do on B? So it's being attracted, right?
Wouldn't it away? No. Yeah.
It's moving towards the negative side.
Yeah, it is moving.
Yeah. A is moving downwards towards the negative sign, right? Okay. And this is going down, so I should also say up and right are positive. So if this is going downwards, we're actually going to say negative. I'm just gonna write. Okay, I carried all of my decimal places. Okay. So that is force of B on A. Now I need to jump in with a new slide. Okay, and let's find
It's
the
not possible for me.
force of C on A. So you guys have the picture in front of you, which is nice. Let's have the notes. So F of C on A is K times 0.8 times 10 to the negative 6 coulombs multiplied by the other charge, which is 1 times 10 to the negative 6 coulombs. And the separation distance there between A and C, careful, between A and C, right?
Oh yeah.
0.1 meter squared. And put those into your calculator, and you will get a force of 0.71922 newtons. And A and C have, what are the charges on A and C?
Repulsion.
Yeah, they're both positive, right? So this is going to be repulsion.
Wait, so we have to find a new vector?
Yeah, we sure do.
Alright.
We sure do. So, A, C. So,
Oh, you're supposed to do
A and C, they are pushing
my part.
one another away. Okay? So, we know that this is 0.7192 newtons. So that is both horizontal and vertical, right? So now we have to split this up into the horizontal force and also the vertical force. And we need to find our triangle, our angle.
So can you just do it in the original? Yeah.
Yeah, so if we are back here, for our angle, what do we get? 30, I got an angle here of 36.87 degrees. So again, if you do opposite over adjacent,
36.86?
sorry?
36.86?
36.87, I think I rounded up one, but you should store that value into your calculator because we will want to use that, okay? So there is our triangle, so 36.87 is our degrees. Now we can find f of x and f of y. So just kind of like what we were doing in our first unit, right? We need to do horizontal and vertical components, right? Because this one is, well, not horizontal and vertical, right? It's at an angle. Okay, so we can find, so F, C on A in the X.
We have to keep direction here too, right?
Yeah, we do have to be careful with that for sure. Yeah, good question. Okay, so FC on A in the horizontal component is going to be the sine of 37, and don't round, don't use 37, I just use that for space. Sine of 37 multiplied by 0.7192 newtons, which is equal to 0.43 newtons. And again, A and C are both positive, so again, this will be repulsion, right? A and C are both positive, yeah. Okay, so that is in the horizontal. Okay, so let's find our vertical now. So FC on AY is equal to the cosine of 37 multiplied by our hypotenuse. And if we do that, we get 0.5736 newtons of repulsion again. Okay, great.
So what do you do those?
What do we do with those? That's a really good question.
You have to add the y to the other one. But
Yep.
no, that y is going to be negative.
Perfect. Okay, so we need to combine our horizontal and vertical components, right?
Oh,
So-
find another vector.
Yeah, remember B.
Jeez.
So B would be vertical, right? So let's do that right now. Okay. So remember the force of V on A. I'll use a different color. Force of B on A was 0.67425 newtons of attraction. Okay, so B is like pulling A towards it, right? But C is also kind of like pushing A away too, right? So there's a little bit of a play in there. So we'll do F net Y. Are you guys okay if I do it on here? Down here? Yeah, great. So F net Y. So we have F net Y of A is equal to F net B on A in the Y direction plus F net of C on A. Yeah. In the Y direction. And this was also in the Y. Oops, that wasn't supposed to be red. Okay, so we had attraction and we also had repulsion. So attraction is going to be, so attraction FB on A is acting in a negative, so it's coming down, so this should be negative. And FC on AY is being repulsed, so it is pushing it upwards, right? Because A wants to come towards B, but C is still like, no, like get away, right? So there's like a little bit of interplay going on between that. Are we all good so far? Yeah? Okay, so we have attraction from A to B, so B is pulling A down, but C is still pushing A away. So B on AY is negative because it's pulling it down in the negative, in the downward direction. So we have negative 0.67425 newtons plus 0.5757.536 newtons. And I ran out of space there. Is equal to negative 0.099 newtons. Sorry, that's really small. Can you guys see that okay? I got F net Y is equal to negative 0.099 newtons. Good? Yeah. Okay, so the net the net vertical direction, A is coming down a little bit still, right? Because we have a negative direction, so it's coming down a little bit. Good? So far? Aaron?
Yeah.
Good?
Is that it?
No.
I was like, wait, that's not.
No, so I'm gonna jump and do, actually we're probably not gonna have enough time to finish this. So let me tell you the answer, and then we can go over it tomorrow. We're really close. So FE net A is 0.44 newtons. Okay, that is the solution. So what's left here? We know F net Y. This is. Do we have anything else acting in the X direction? No, it's just your horizontal force from C on A.
Wait, why would it be south?
Which one's the origin?
South of
Which one's the origin though?
the origin. So A is going to be the origin. So it's being pushed this way.
Yeah.
Yeah, we'll finish this tomorrow.
Yeah. Because look,